Hello, Daisy. Hello, everyone. Hello, and hello especially to our mascot. We have a mascot today, guys. Arthur. Yes. Someone asked me the other day, they're like, do you think he knows his name? And I was like, yeah, it's a cat. He's not an idiot. Like, what do you mean? And they're like, well, he doesn't respond to it. I'm like, again, he's a cat. Of course he doesn't respond to it. I saw a meme the other day which claimed, internet, but it claimed that research has actually shown that cats know their name and just choose to ignore it. And I absolutely believe that. Seems completely plausible to me. I'm going to open a soda. This might be loud. I'm going to mute myself. Hold on. This can sound strange, but I had a dream as a kid once. I had a dream that I opened a soda and slit my finger open, and the bone came out. And so ever since, I've always been terrified of like cutting my finger on a. It's like pathologic. I'm always like super careful when I open cans of soda. I know it's weird. It's like one of the. I don't know. Like I actually thought for years that it actually happened. And then I told my mom one day, and she was like, that never happened. And I was like, but I was at Dad's office, you weren't there, and like it healed. I just like tucked my finger back together and it healed. And she was like, that didn't happen. And in retrospect, it wouldn't make any sense. But I thought for years that it was real, like it actually happened. So I didn't, because I was like a little kid. So I thought it's deep in there. Oh, well, welcome back to Monday. The third to last Monday. It's pretty wild. I've got my headset on. Actually, I tried something else earlier and it worked better. I'm going to do that instead. I got set up with a little Bluetooth speaker that I ran a headphone cable into from my computer so that I can have some sound that's not on my headset, which is important because my headset is wireless, so it turns itself off every few minutes if I don't have any sound going. So, and then I missed chat messages. Okay, let me get my stream thing going, and we'll get started. So, just to kind of look at the calendar here. So as you can see above my head, we are on the 13th, Monday the 13th, and the last day of class is Monday, April 27th. Our last day of class is in two weeks. Hey, Mo. How's it going? Hello, Dorothy. Hello, Michelle. Hello, Nora. I didn't say hello to everybody. I'm sorry. I should do that. It's going good. Good. I don't know about you guys, but it was I wouldn't say it was a beautiful day today in Knoxville, but it was a little overcast to really be beautiful, but it was pretty nice, It was a little chilly. It was like, I don't know, it was below 60. I don't know what it was. It was pretty warm. It was the wind that was really the killer. It would have been fine, but it wasn't sunny and it was windy. Yeah. It felt like I saw 59 on the temperature and I was like, oh, it's gonna be warm outside. And I walked out and I was like, this doesn't feel like 59. I guess because it really rained hard, so it was really humid, and that no sun and windy, and it just sucked the heat. Whew, it was cold. Okay, let's get to it. So, just a reminder, if you ever have any questions, if you ever missed the first part of the lecture, if you ever need a recap on what's to come, syllabus and announcements. This is your friend. I put everything that you need to know in here, at least in terms of what's to come. Now, of course, that doesn't substitute for an actual lecture, but at least in terms of what's your schedule or whatever. Okay, so let me move my head out of the way. I'm not sure that really matters, but okay. Moves a little bit off protects the text a little bit. Okay, so reminder, we have 2 weeks left to fill out the University Climate Study. And also a reminder, if you don't know this, your exam 2 is due by midnight tonight. So if you missed the sign up on Friday, you need to let me know, now, because it is really running out of time. Hey, Freddie. Hello, hello. Welcome, welcome. I just washed my hands, I promise. It's allergies. I just washed my hands. They're nice and clean, so I can touch my face while I talk all I want. Just saying it. Okay, so I was showing you the calendar because this is crazy, guys. This is absolutely wild. Can I highlight this? No. Look at this right here. We have 5 class periods left. But because of things like quiz, in-class assignment, vocab quizzes, these kinds of things, we're going to lose a whole class period. So we basically have 4 days of lecture to cover 3 chapters, which is obviously a stretch. So we're going to be really cherry picking key concepts. Just 5. Just 5. There's 5. I tried to think of a joke about that, but I couldn't come up with one fast enough. So we're cherry picking concepts. It's basically going to be each chapter is a day with maybe a bit extra. So we'll have 10 minutes left after today of chapter 7. So we are going to skip the finite populations discussion and the discussion about population proportions. Although there's an asterisk on the finite populations part, that's the first part of the chapter. So there are some introductory bits that apply to both finite and infinite populations. So we need to talk about that. Those introductory bits. So there's only there's one slide we'll skip entirely, and then there's some later things where it's broken down based on whether you have finite or infinite populations, and we'll be ignoring all the things about finite. And that'll let us get past the fact that finite and infinite are pronounced differently, and that irritates me. Why isn't it infinite and finite, or finite and infinite? We'll never know. Or someone who's a linguist can tell me. I have a good friend who's a linguist, and she's always good about she's like, well, let me tell you, Rob, because she knows I actually do want to know. And so she'll educate me. It's great. She's a PhD student at UT Arlington in linguistics. Okay, so we're going to compress. I will give you more bullet points on Chapter 8 and Chapter 9 in terms of what we're skipping when I actually know. I'm dealing with that as it comes. I've been stretched thin for this exam, trying to figure out format last week, and then actually getting everything in the computer, actually getting everything working has been a real test. No pun intended. It's been a big challenge. And, lots of people didn't fill out the survey, and then trying to deal with that, and then, I made some mistakes. I had to put in, I'm estimating something like 400 exam dates and times. And it's not you just type it in. You have to click on all the drop downs. And so if you miss one or misclick something or whatever, it's really easy to make a mistake. So I have made a few mistakes, gotten things on the wrong day. I don't think I've missed any times, but I've missed several days. So had to go back and fix those. So I've spent, at least 6 hours. I did at least 6 hours of work of answering emails yesterday and today. Just troubleshooting with people's emails and getting scheduling stuff sorted out. It's been a nightmare. At least 6 hours in 2 days. It's been really rough. Daisy, run that by me again. Did over the weekend everything? Try. Not sure what you were going for there. While you're typing that, here's what we got coming up. So I'm going to give you, let me step back a little bit. Okay, so we're going to do most of Chapter 7 today, or at least the other parts we're going to do. And then we'll touch on, did I put all the week exams over the weekend? Most of them. You're not able to take Part 1 Exam 2? You mean Exam 2 Part 1 or Part 2? Which one? Because I thought I checked it. Didn't I fix it? Oops. I thought I fixed it. Or wait, did you tell me that you could? I think If you can't hear me, check for the mute at the bottom, which you wouldn't be able to hear me. Low something. It's hard for me to troubleshoot you based on the word something. If you can get the error message again, let me know. Of course, you can't hear me. Oh, you got it? Okay. Exam 2, Part 1. Okay, where'd you go? There you are, Jessica, at 9 p.m. Doing it right now. See it on the screen. 9 p.m. till 9:35 p.m. Okay. Thought I already fixed it. Obviously, I didn't. I might have changed the wrong one. I think it's not important. I think either I read it wrong or you typed it wrong. One of the two. I'm not sure which one. Because I'm pretty sure you said part 2 in your email and the message on Discord. But I could have made a mistake as well. I don't know. Okay, did I put yours in? For what? So I have this big spreadsheet where I kept track of everyone's times they wanted, and then I turned them green as I got them typed in. These blank. There's one or two over here that I didn't talked to recently that isn't in here, but you can see it's a lot of people, so it's hard for me to keep track of everybody. Yeah, there's about 400 different things I had to type in, and you saw how it works, right? Like I go in one person at a time, type in a date, type in a time for like 80 people for 5 portions each. It was awful. I'm not going to lie. You're part 4 into part 5. I think so. Unfortunately, I don't have an easy way to check. This is part of the pain in the butt. Is the only way for me to check is to say part 5, restrictions, and then scroll down. Tonight at 9 o'clock to 9:35. So that one's there. Right here. You see that? That's you. And you can just check, by the way. If you go to your own quizzes up here, you can see yours. I can check part 5 as well. Oops. Part 5. Yeah, you can just go to quizzes and it'll tell you if you can see them. Okay, restrictions. Oh, I have them both at 9 o'clock. Wait. You wanted it at 8:30 and then, hold on. I think I clicked on the wrong one. Let me check. Oh, that's not good, Jessica. Give me a second. I'll fix it. Yeah, 8:30. 8:30 and 9. Mo, yours is good. I messed up on Jessica's. As you can see, this has happened a lot. Well, actually, I shouldn't say it's happened a lot. It's happened several times. Mostly, actually, the errors have been on the side of the student. Either by not signing up at all or by actually making a mistake in what they entered or needing to change something. I've actually been surprised at how few mistakes I made. I only made about 6 or 7, which is surprisingly small. With 400, that's like 1 or 2%. It's pretty low. And I made most of the mistakes last night because I changed the system I had made. It's faster, but not as accurate. Okay. Am I still planning on doing an exam on the final chapters? And then if we want a cumulative exam? Yes. In fact, you got it? Okay. Sorry. I don't know how many tries. Apparently, it's going to take me like 6 tries to get it right. Sorry. It shouldn't be that hard. It's my fault. Michelle, let me tell you more about that in just a second. Okay, so here's what we got left. We got Chapter 7 today. We got Chapter 8 and Chapter 9 will be spread out between Wednesday of this week and then classes next week. And then depending on how I do things, we may not have lecture at all after next week. meaning we'll spend class time on Monday doing like in-class assignments and quiz and maybe extra credit kinds of things. I'm not really sure. Or we'll do some of that on Wednesday and spread it out. So we'll do a bit more lecture on Monday, but I'd kind of like to have the lectures just wrapped up. So we'll see how things go. So I'll let you know once I get that actually decided. But here's your assignments. Here's what's coming assignment-wise. So we're going to do a Chapter 7 mind tap homework. Hold on, Daisy. I'll get to that. Just like Michelle's question. Your question's related to Michelle's. I'll get to you. I'll get to that question. So here's what's coming up. Chapter 7 mind tap homework will be due Sunday at midnight. Sunday, April 19th at midnight. I had students ask, they wanted to do it right before class. It didn't go well. It ran into some problems. We're doing midnight. We're doing midnight. All right. Now I haven't posted it yet because I have to take some questions out because we're reducing the chapter, but it'll be there soon. And then I've got to give my analytics class some attention first, so it's going to be probably a couple days before it's there. Okay, so mind tap homework assignment due Sunday at midnight. This coming Wednesday, even though Chapter 7 will largely be finished, we're going to have a vocabulary quiz at the start of class on Wednesday for Chapter 7. Now, Chapter 7 has 21 words, and a lot of them, it is not that. Some of the words are not relevant because we're skipping them, or not that important, so I don't want you to spend forever memorizing them. So I'm going to cut down a list of words, and I'll post it to D2L on the links to online learning resources page where I'm putting almost everything that's new. I've started reducing that. I haven't finished. So I will get that done right after class and get that uploaded. Next week, we'll do Chapter 8 and Chapter 9 vocabulary quizzes, Monday and Wednesday, respectively. I'm not going to cut them down because they're already short lists, 9 and 10 words each, respectively. So there's not that many words to memorize, so I'm not worried about having you guys cut it down. So like I said, finally, as a final remark, we will have at least one quiz and at least one in-class assignment left. I haven't even graded the first ones, and I know that's obviously important. I'm trying to get through. I'm struggling just to keep up with all the things that we have to do, part of which is my own fault for making an exam complicated and whatever. But, that's part of the transition to online is figuring out what's good and what works and what doesn't work. So I will evaluate. A lot of students seem very unhappy with this exam format. So even though I think it's a good thing overall, a lot of students weren't happy with it. So I don't know. Maybe they'd be happier if they did it again, but I don't know. I might have to change something because having a survey to fill out and be told and get to decide when you take your exams was apparently too much to deal with for a lot of students. So I'm not really sure what to do with that. I got a lot of that, and I got several students that gave me negative feedback, even though it's supposed to be helpful. So I don't know. We'll see. I might still do it this way. It was a huge pain in the butt to then have people mad at me for it. Was pretty dissatisfying. Anyway, so you're supposed to have, according to the syllabus, 3 quizzes and 3 in-class assignments, and as Michelle was alluding, 4 exams. Well, so far, we have now, for most of you anyway, have done 2 exams, and everyone has done 1 quiz and 1 in-class assignment. So you can see we're, hurting for getting those assignments knocked out. So what I'm thinking is that we will do 1 quiz and 1 in-class assignment in the next week and a half, meaning, let me be more clear, not this week, but next week and then the week following, like Monday specifically, of the 2 weeks later, the 27th. Let me start over. I'm pretty sure we will do an in-class assignment on Monday the 27th. My question is, will I do a quiz on that day as well, or will I do a quiz on Wednesday beforehand? Not really sure. But either way, there's no way we're going to do a 3rd quiz and a 3rd in-class assignment next week. Like, it's just not reasonable. But because I promised you that you'd have that 3rd way to kind of, dilute a bad score, I want to give you that opportunity. Now, at the same time, I haven't graded them yet. So, one option is just to be like, well, we're not having a third assignment, so I'll just have to grade really generously. And I'll probably be pretty flexible with that, to at least to a degree. The other option is that I can give you an optional third quiz and third in-class assignment, although I've put quotation marks around it here, in-class assignment, because it's not going to be in class, during finals week. So, yes, Michelle, we're still going to have a third exam. That will be during finals week. And then I will also give you an optional final exam. And so it'll be another exam, except that this one will be cumulative. So what I would probably do is kind of similar to how we did this exam where you had 5 portions. Instead, you'd have 3. And each one would be like 1 unit. And then whatever the day of our final exam is, I think it's either Wednesday or Thursday, I would say, like, during this day, you can take those 3 sections whenever you want, similar to how we did. You would just sign up for it and tell me which one to do. Alternatively, I do know now that there is a way that I can set it up so that if you well, it wouldn't be very helpful. There's a thing I can do, but I don't think it's worth it. I think it's better to just do the format like we did today, or I just make it during the final exam slot, and everyone's got to take it during that time, which is tempting. That might be what we do, just simpler that way. So I'll be thinking about that in the coming days, and I'll let you know. But either way, so my point is that the optional third quiz, optional in-class assignment, what optional means is that I'd be giving everyone, in a sense, everyone has 3 quizzes, 3 in-class assignment, but you get a drop for, you get a dropped quiz and a dropped in-class assignment. So if you choose to not take the third quiz and the third in-class assignment, you will, of course, get a 0. You don't complete the assignment, you will get a 0. So your 0's dropped. It just goes away. And it's like it was never there. Or you can attempt the third one. If you do poorly, it goes away anyway. If you do well, then you'll drop one of your previous scores. So that's a fairly simple thing to do. I will consider doing that. Gabby, in terms of a cumulative prep exam, the short answer is no, or is the short answer yes? Depends on how you look at it. I'm not going to give you a new prep exam. It's basically just the 3 previous prep exams, which are still on D2L. You can access them at any time. The first prep exam is obviously in paper format, whereas the second one is digital. Is the D2L quiz sort of thing. But the idea is that the final exam is just the 3 previous exams again, basically. Obviously, it's not the same exact questions as it was the first time, but it's the same concepts, the same problems, the same whatever. So the prep is exactly the same as before. So you will have an exam prep for exam 3. You will not get a new exam prep for the final exam because you can just use the same ones you already had. So there's no reason to have another one. Okay, so if that's confusing, I will give you more information, partially because I haven't entirely decided how it's going to work. I just wanted to kind of give you a heads up what was going to happen. I did not put this on the slides, but there will be mind tap assignments for 8 and 9. We'll worry about when they're going to be due based on when we finish them. So, Mo, when you submit your submission, it tells you the score. And then if you want to redo it, you just go back to quizzes and click on the thing to go again. So you have 30 minutes, and in that 30-minute interval, it's like on a paper exam. If you look at your grade, if you look at your thing and you're like, oh, I didn't get one of the multiple choice options, you could erase it and do it again. It's kind of like that, except that you actually get to know if you have the right answer or not. How is it possible within 30 minutes? Well, if you're comfortable with the material, there is enough time to do. Yeah, you have to work through it. But the longest section had 5 questions, or was it 6? So I think I think it was part 4 is the one that people tended to have the fewest amount of time left. But there were especially parts 1 and 5. people would have as much as like 20 minutes left after submitting their first submission. But none of the parts, if you know what you're doing, take a long time. They're all pretty quick. However, like there are some that are longer than others, and the less comfortable you are with the topic, the longer it takes. So, yeah, it's all probability. Yeah, see, like that's what I'm talking about. Like for like Ben was very quick, which is faster than most people for the record. Like I say, 4 minutes is well, yeah. I mean, so at some point you have to know it. Like there comes a point when. So one of the things that's really brutal, not to use Jessica's word, but the truth is that there comes a point when more time doesn't help. And I've tried. Like I've given students a really long time on exams, and it does not help. It just makes the experience more painful for both of us. Usually I've been proctoring in person, but yeah. Part four does seem to be hard. How about the missed typo? Well, Dorothy, yeah. So Nora, if you know it, you know it. If you don't know it, you don't know it. That's kind of how probability works. If you're having trouble, then yeah. So more practice, it'll get better. More time, is what it is. As for there is a question that I'm probably going to be throwing out. However, because half of the students had already taken the exam, it's not fair to alter the exam for the other students. So I'm not going to tell you what question it was. And I'm not going to take it out until everyone's had a chance to finish the exam. So we still have students left taking it. So I will give you more information on that on Wednesday. So I haven't forgotten. It's just a secret right now. You're ruining it. I'm just kidding. Yeah, I thought about taking it out from straight away, but I want everyone to have the same experience on the exam, for fairness. You already had to suffer. They might as well have to as well, right? I'm mostly kidding. Daisy, I missed that part. I finished my exam around 6:30. Can I go back and try another attempt still? Let me look at it later, potentially. You have 30 minutes per section, so if you finished at the half hour, you probably don't have any time left. But I can go look. Well, I mean, sometimes you need more practice. Or guided practice, or you need to ask questions, or there's only so much I can tell you, right now, in this moment in lecture. Beyond that, some of it we'll have to look at together to figure out what to do to make it better. I'm sorry that you were frustrated. No, you don't have to apologize, Daisy. I'm just saying that, we knew the practice exam wasn't going to be perfectly representative of the actual exam because the actual exam format is restricted, whereas the practice exam isn't. So the restrictions portion is not going to be practiced by the practice exam, if that makes any sense. Hey, you know what? Crazy idea here. I know my face is shrouded in shadow, which on one hand really gets like the mysterious, spooky teacher vibe. I'm going to shine a flashlight in my face from my phone. That's actually kind of really annoying. Ooh, that's awful. How about this? Does that even the light out pretty well? That seems okay. It's a bit inconsistent, but it's pretty close. It's better than it was, right? This is before. That is actually my goal, to make homework harder. If homework is harder than the actual exam, that's intended. I won't say it's like a good thing necessarily. I think it is. I do it on purpose, but I've always felt that as a student, well, on some ways that was really frustrating. So I had one class that I did not pass a homework after the midterm. and I made an 87 on the final. So on one hand, I was incredibly relieved, but I actually requested an additional year of grad school because I was like, I can't pass this class. And they said, Rob, no one passes the homework, so you're fine. And I was like, wait, what? No one can do the homework? Well, then why do we do it this way? Oh yeah, you're fine. You're in the top like third of the class. And I was like, okay, whatever. Oh yeah, I almost made a 90 on the exam. Okay, I do know what I'm doing, I guess. It was the hardest class I ever took. Graduate math course. Ew. It didn't happen. Pretend it didn't happen. It was awful. Okay, so here is the lecture. We got to get moving. We got stuff to talk about. So we have it's open on MindTap. Yeah, don't do it on MindTap. I'm just gonna turn it off. It should be available. Actually, I didn't think about that. Yeah, it's available by default, so I need to turn it off. Thank you for telling me this. Come on, Cengage. You can do it. I believe in you. That's my analytics class. I need these. I need that. I'm not entirely sure what happens if I try to edit one that's already been started. Probably it's not good. Come on. Batch actions. Hide. Okay. And you guys, that was my earlier section. Chapter 7, edit. Oh. And the back button doesn't work. Awesome. Okay. Good. Thank you for telling me. Now we can fix that later. Okay. This is really dazzling. Oh, it's not a perfect solution, but here we are. Okay, so everything that we've done up until now is sort of like, I don't know, I think of it like a pyramid, that we've laid groundwork, and then we've shaped, and we've built, and we've shaped, and we've built, and we've shaped, and we've built. And now we're at the top portion of the pyramid. So we're not at the pinnacle, not at the tip, but we are at the top part now. We're, 3 rungs from the end, or 2 rungs from the end. There's 7, and there's 8, and there's 9. So we have built up the fundamentals of statistics, and then we developed the fundamentals of probability, and then we'll now be applying this to general terms, general tools that are useful for a variety of circumstances. In fact, they're quite general. They're useful for almost anything. And so that's where this class should hopefully be getting more and more exciting. I recognize that most people don't, go, oh boy, Poisson distribution. I get it. It's not sexy. But we're starting to be able to answer cooler and cooler questions as we go throughout. Now, Chapter 7 is probably the least exciting of the chapters around it. Chapters 8 and 9 are definitely more interesting. But again, it's a pyramid. We're building our way towards something quite useful. So the whole point of today, and today and a little bit of next time, is to discuss sampling and sampling distributions, which is basically talking about how do we use samples, how do we take from populations to make interesting, educated guesses about population parameters. So that's what we're going to do. Let me hide this presenter view so I can still see the chat. And so there's several components that we'll talk about. Obviously, we're going to skip this entire portion about the sampling distribution of p-bar because that's the proportion thing, which I suppose at this point isn't obvious. It doesn't matter. We're going to ignore this, and then we're going to ignore part of the bit about finite populations. Okay, so just kind of remember, elements are entities on which data are collected. A population is a collection of all the elements of interest, and a sample is a subset of the population. So those are not new terms. We've had them before. We've had them for several chapters, in fact, but they're still relevant. Again, this is a pyramid. It's all building on itself. It's all relevant to each other, and we are reaching the pinnacle. So the new thing we have Oh, sorry, I skipped this one. The sampled population is the population from which the sample is drawn, which, as we'll say later, hopefully is the same thing as just the population of interest, but not necessarily. Okay, so here's the new one, frame. A frame is a list of the elements that the sample will be selected from, which sometimes it's like a predefined list usually. And again, you'll see what that means here in a little bit. Now remember, what are we doing this all for? Because why are we sampling? Why are we taking samples? Why are we collecting data? Because we're trying to answer research questions, right? We have something that we're interested in, whether it's, I don't know, income levels or political affiliation or, their opinions on season 8 of Game of Thrones, in which case there's only one right answer. Which, by the way, apparently George R.R. Martin tweeted that the year 2020 was written by him, and someone retweeted that it was still better than season 8. And that made me laugh. You kind of walked into that one, I think. Okay, now, here's the thing. Populations are populations. Samples are not populations. Samples are part of a population, which means that if we use samples to make statements about the population, then we are only providing estimates of the population characteristics. We don't have perfect information. So, we need more information because our sample only contains a portion of the population. So we can't just compute the sample statistics and say, great, that's the population parameter. It's not. It's hopefully probably close, but it's not exactly right. Now, the good news is if we use proper sampling methods, which means, theoretically grounded sampling methods, and using the formulas and stuff we've taught in class and some more advanced concepts, then the samples that we get can provide good estimates of the population characteristics. Note the word good is in quotation marks. It doesn't mean they're like perfect. It's just, reasonable. Probably. Okay, so the difference here, we're not going to talk about finite populations, but we do need to discuss the differences. So a finite population is usually defined by a list, whether that's an organization membership roster, a list of credit card account numbers owned by a bank, inventory product numbers, something. List of, products that McDonald's sells. It doesn't matter. Like some list, something defined. In that case, it's quite easy to take samples because all we have to do is just choose a portion of them and just, make sure that anything that you're choosing is random, that you don't have like a bias towards one thing or another. So like the formal definition, the formal way of saying this is that each possible sample is as equally likely as any other sample, which I don't know. It's usually easier to think about it as saying any individual item has the same chance of being created as any other, as being chosen as any other item. Kind of same idea. Okay, now 2 ideas we've talked about before that we need to talk about again, which is sampling with replacement and sampling without replacement. I like to use the example of candy in a bag. If you take it out and eat it, that's sampling without replacement. If you take it out, look at it, and put it back, that's sampling with replacement. And then when large sampling projects, we're of course going to use a computer. Computer generates random numbers, and that's used to automate the sample selection process in one of a number of ways. There's lots of ways we can do this. And we'll talk a little bit about it in analytics, in business analytics and Management 379, but we're not really going to talk about the details in this class. Okay, so here's the example problem that we'll use in this chapter. A college, St. Andrew's College, a fictional college, has received 900 applications for admission in the upcoming year from prospective students. The applicants are numbered as the applications arrive, arbitrarily from 1 to 900, just chronological order, doesn't actually mean anything. And the director of admissions wants to select a simple random sample, so just random sample of 30 applicants. So there's a little process here, but it doesn't really, we're not too worried about it because we're only talking about infinite populations. However, we are going to want to talk about that problem in a bit. Because in that case, it's quite well defined, like we have 900 items. But usually, and what we're going to talk about for the rest of this class, is that often when we're selecting a sample, it's not possible to obtain a list of all elements in the population. Maybe it's something like the people who bought from a particular McDonald's in this year. Well, some of them paid cash. So I might maybe be able to scrape credit card data to know who bought things with card, but I'll never know who came in and paid cash. In other times, it may be impossible to list because it is an ongoing process. And so we cannot construct a frame for this population, and we cannot use our random number selection process. So this is often in infinite population cases like an ongoing process, but it can happen in niche cases like I was talking about, like, well, we're not tracking it. So it's impossible to know who actually was there. We could look at the credit card data, but then that would be misleading because we're only looking at populations that pay with the credit card, which has some suggestions, some implications about perhaps technological affinity or financial status, some kind of demographic information like that. But more commonly, this is an ongoing process. So there are a lot of things, like I gave the example of going to McDonald's. Well, what about the customers that have gone to a McDonald's ever? Any McDonald's? Well, that population is dynamic. It's changing over time because anytime that a new person goes to McDonald's, they're added to that list. And that will continue forever. As long as McDonald's is in business, new people will be born and new people will go to McDonald's. And if new people stop being born, then we'll probably stop caring about who goes to McDonald's because we'll have bigger problems to worry about. So for the practical purposes, it's an infinite process. There is no upper limit on the number of units that can be generated. And here's some more examples. If you feel the need to review these, you can pause the video when you come back and watch it. So in this case, we must select a random sample in a different way. It's not the same kind of simple random sample. We can't use the computer, but we have to do some kind of random sampling to make valid statistical inferences about our population. Because we can't do the easy way to make sure we just choose random numbers, we have to make sure these two conditions are satisfied. Each element selected comes from the population of interest, and each element is selected independently. However, that second one is a lot harder than it sounds. Each element is selected independently. So there's extreme bad examples like, oh, well, I've assumed that this person identifies as a woman, and so I'm going to pick my next person that looks like they identify as a man. Like, judging based off of your perception of gender is not a good idea. But it goes so much deeper than that. Like, let's say, for example, I'm interested in studying college students. Well, I'm a college professor, so I would have ready access to a large number of college students in my office building, right? University, the campus, right? However, in that case, the sample population would be students at NEIU, and quite possibly students at NEIU in the College of Business, physically in the College of Business, which might not necessarily be business majors, but it probably is. So not only have I biased myself based off of a university, but I've also biased myself based on a major. So just using that convenient sample in front of me will really potentially bias my sample away from truly being an independent selection. So it'd be far better if I somehow had a way to access students across the country, whether they're, Chicago or, I don't know, Case Western Reserve, or maybe some small school in Kentucky, or, I don't know, middle Minnesota, Oregon. We need to be able to access students from anywhere, not just business students in Chicago. So it's harder than it sounds. Okay, so all of this is about making estimates about the future, about the population, and so we're not just interested in this, but this is a good place to start. So for now, there are two major statistical concepts that we've talked about. Come on, give me some slack. There are two major concepts we've talked about in detail, and we're going to start talking about how our samples teach us, inform us about the equivalent value in the population, and that is called a point estimate or a point estimation. So this is a form of statistical inference. We're using data from a sample to compute a value of a sample statistic. and then we use the sample statistic as an estimate of the population parameter. All right? So the good news is this actually isn't new. It's just a different language. It's a different way of referring to what we've already been doing. So you've seen X bar before, right? That's the sample statistic for the population average, mu. We called it, now we're going to call it the point estimator of the population mean, mu. Similarly, S is our point estimator of the population standard deviation, sigma. And then if we were going to talk about it, we would use P bar as the point estimator of the population proportion P. But again, we're going to skip this part. It's not that it's not worth talking about. We just don't have time for it in today's in pandemics. Don't tear up my chair. Oh, he giving me a sassy look. You can see half of him, right? Oh, he's sleepy. He's doing one of these. He's so cute. Okay, so let's go back to St. Andrews College. So here's where we're going to start taking a look. So they got 900 applicants, which is technically a finite population, but it's big enough that we can pretend that doesn't matter. So the application form contains a variety of information, and we're going to focus on their Scholastic Aptitude Test Score, their SAT. This example problem also includes the whether or not the individual desires on-campus housing, but that's relevant to the population proportion, and we don't care right now. Now, at a meeting in a few hours, the director of admissions would like to announce the average SAT score for the population of 900 applicants. However, the necessary data on the applicants have not yet been entered into the college's computerized database, which you'd be surprised at how often different systems don't talk to each other, and you have to manually convert from one to another, or how much paperwork involved in today's day and age. It's not digitized. You'd be surprised. So the director decides to estimate the values of the population parameters of interest based on sample statistics. So we'll use that computer random generation system to select 30 applicants. So if we use the same procedures we learned in chapter 2, to average all the SAT scores, you'd add them all up, divide by 30. In this case, the sum of all the SAT scores is about 50,500 divided by 30. It gives us an average SAT score computed to be 1,684, or a 1684, as it's usually referred to. Similarly, the sample standard deviation is computed to be 85.2. And if we cared about the sample proportion, it would be 0.67. Now, it is very important to remember that the sample statistics, easy for me to say, sample statistics are dependent entirely on what sample is chosen. So, fun fact, take a guess, give me some guesses in chat. How many possibilities do you think there are? How many different ways of sampling 900 students and choosing 30? How many would you guess? Give me some guesses in chat. What do you think? I looked up the answer in my previous class, so I'll tell you. A lot. You're right. Okay, I'll give you a hint. 9.8. Here's the question, though. 9.8 times 10 to the what? How many zeros do you think goes after 98? It's more than 98 billion. Here, I'm going to mute myself, so I'll go ahead and type out the answer. Are you ready? $54 zeros. It's basically 10 to the 55th power. Or 10 to the 55th power. Which, for reference, most estimates for the number of atoms in the universe is like 10 to the 60th or something. So it's like, within a couple factors of the number of atoms in the universe are the number of ways you can sample this. So, you know what? Nor summed it up perfectly. It's a lot. There are a lot of possible samples. And each of these different samples, there's some overlap, of course, but different samples are going to produce different averages. So there's a very large number of possibilities for each of these samples. And they might have maybe they'll have the same mean, but then they might have a different standard deviation or a different proportion. So you might have some statistics that are the same, but then other statistics would differ. So we start having these questions about, well, if there are so many different options, different possible outcomes, then how do I know that these that we've found are worth anything? Truth is, to a degree, you don't. However, we can make some sort of probabilistic statements, as we've learned to do in chapters 5 and 6. Oh, I'm selecting the chat, not the slides. Okay, so keep in mind the statistics that we computed for our sample are 1684 and 85.2 for our standard deviation, which, by the way, this formula was... this is just the same standard deviation formula. We've seen both these before, seen them for ages, nothing new. 1684 and 85.2. So the actual mean, 1697. Because again, we only have 900 applicants, so it's not hard to compute the actual mean and the actual standard deviation using computerized software. So we're pretty close, right? 1697 versus 1684. This 5520, Michelle, is pretty much just, if they had actually shown us the sample, we would have added together all the SAT values. Sorry. SAP is a software, SAT is the testing score. So, in practice, I'll just give you these. I'm not going to make you compute them, probably. Maybe like on a mind tap assignment, but not for an exam. Maybe I would. It's just you add up all the points and divide by how many points there are. I just didn't spell them out for you for the sake of brevity. Okay, so we're within like 15 or something here, and then about 2 points off here. So overall, pretty close, but not perfect. We did not get exactly the right answers. We were pretty close, though. So here's a little table comparing what we should have gotten, or like what the true values were with our estimate. So you can see we are 13 points low on our X bar, and we are 2.2 values low on the sigma. So our estimates are, all things considered, pretty close, like a couple percent. That's reasonably close. It's hard to be too upset if you're only off by 2%, right? That's a 98 out of 100. Most people will take that. Yeah, no worries, Michelle. No worries. Good questions. I wish my answer were more exciting. It's just not. It's a pretty boring response. I'm sorry. Wish I could do more for you. Okay, so we've talked about populations. We talked about sampled populations. And then I kind of alluded to the fact that there is a difference between the target population, potentially a difference, between the target population and the sampled population. So if my target population is all college students in the U.S. and I actually sample NEIU college students in the College of Business, that's not the same thing. So it's important to try to make sure as close as you can that your targeted population and your sampled population are the same. That's what this slide says. We've kind of already talked about it. Okay, so we've talked about distributions before, right? We talked about binomial, we talked about uniform, we talked about normal, we talked about hypergeometric briefly. We talked about, what else? Did I say binomial already? Exponential. There's one I'm missing. We've talked about several distributions. Well, there is a specific distribution, which is to say a sampling distribution, which is all of the different ways you can get a sample average. So if I looked at the 9.8 times 10 to the 55th, 9.8 times 10 to the 55th possible samples, and I took the mean of all of those samples, and then I plotted them in a histogram, that would be essentially a graph of the sampling distribution. So it's all of the possible sample averages, and it's a distribution for how likely they would be. If it is true that the expected value of x bar, which is our sample average, if the expected value of our sample average is actually the true population mean, then we say that this point estimator is unbiased. And we say that for any different point estimator. So it doesn't have to be a point estimator of the mean, which is what this example is, but it could be the point estimator for the standard deviation or any other number. I don't know, median, skewness, kurtosis, any of these other measures. The mean is the most important one. So we want the expected value of our sampling distribution to be the actual population proportion. That is very important for the estimator to be unbiased. Now, skipping this first one here, this is new. We'll come back to this. These other three notations we've seen before. So let's recap them, and then we'll come back to the first one. So sigma, the standard deviation of the population. Capital N is our population size. So both of those are for the population. And then lowercase n is the sample size. So we have a population of size capital N and a variation of it, which is sigma. And then we take a sample of size n, and the standard deviation of that sampling distribution is sigma with a subscript of x bar, which is exactly the same sigma, we just add a subscript. If there's no subscript, we assume that to be the standard deviation of the population. If there is a subscript, then it tells us which point estimator we're referring to. In this case, x bar. Otherwise, no new notation. Otherwise, exactly the same. Now you can see in finite population, you have this pretty ugly formula. It's not actually that bad, but it's not pretty. Meanwhile, the infinite population formula is quite nice. It's simply the population standard deviation divided by the square root of the sample size. And this is actually not that hard to understand if you think about it, because imagine when you're looking at the population standard deviation, you're looking at the deviation, the amount of variation that there exists between individuals. So just think about a classroom at NEIU. Think about how diverse those classrooms are, right? Everything from ethnic, backgrounds, socioeconomic backgrounds, all of those different things. Just there's lots of different demographics and lots of different ways that represent our students. And so if you look at individual to individual, there's a tremendous amount of variation. However, I think it's largely true that all of our classrooms are like that, right? All of our classrooms are diverse. So in a sense, if you compare one classroom to another, they're quite similar to another because they're both diverse in a lot of the same ways. Sure, they're not going to be exactly the same, but they'll have a lot of similarities, right? We have different cultures, people from, a whole bunch of continents, 4, 5, 6 continents, in every classroom. So if you compare the individuals, there's a tremendous amount of variation. But when you group people together and compare the groups, then there's a lot less variation. So that's what the square root of n does, is it softens the variation, it tempers the variation based on your sample size. So again, we can ignore all of this. In fact, I'm going to kind of doodle. We can ignore this. Oh, shoot. We can ignore this. You can ignore this. You can ignore this. We're not doing any of that. Just worry about infinite population. And I suppose you can worry about this name. It's not that important, but we refer to sigma x bar as the standard error. You will see this if you look on internet forums, or if you try and type in some formulas into Excel, it will sometimes ask you for the standard error, and that's all this means is the sigma x bar. Now, of course, the sigma x bar formula is provided on the formula sheet, so you don't have to actually remember it, but you do need to know what to plug in, where, and when to use it. Okay, so there's a really important principle which says that when a population, we're talking about population, when the population has a normal distribution, the sampling distribution of x bar is also normally distributed. However, it just so happens that sampling distributions tend to be approximately normal, even when you don't have a normal parent population, which is really interesting. So generally, the rule of thumb is that a sample size of 30 is enough that for most populations, the sampling distribution will be approximately normal if your sample size is at least 30. And with really wild niche cases, a sample size of 50 may be needed, but most of the time 30 is more than enough. So it's pretty cool. We can use the normal distribution to approximate the sampling distribution of even the wackiest formulas, the craziest distributions. So we can take something really complicated and we can still use the normal distribution to help us understand it. And that is so powerful. It's so important because the normal distribution is really well behaved, is a statistical term. It's very predictable what's going to happen in normal distributions. So it's a really important result that we can do this. Because we can use our sampling distribution to provide probabilistic information, meaning there's a 30% chance that, there's a 60% chance that. We can make these kinds of probabilistic statements about how close the sample mean is, how close x bar is to the population mean mu. And that is so important. So you've seen in the news, right? They'll say like, oh, well, we took the average customer spends this much money, whatever. And then they might say in the footnote, like, estimated error, plus or minus $5 or something. They'll give you some statement about how far off they think they are. And that kind of, you compute those intervals with this math. This is how these are computed. Now, we're not going to actually do that in this chapter, but we will do that in chapter 9. That's where we're headed, is to be able to make those kinds of statements based on our samples. Now, what I just said, not the most recent thing, but the one before that about taking sampling distributions being approximately normal, is in a sense is essentially what the central limit theorem says, which is that when we're taking samples from a population, the sampling distribution of the sample mean x bar can be approximated by a normal distribution as the sample size becomes large, where large means 30 to 50. So, do you need to memorize this? No, I'm not going to ask you to repeat it on an exam. However, it's extremely important that you understand what we're doing, that we're using a normal distribution to approximate the sampling distribution, and we're going to use that to answer questions about the parent population. And in fact, we're not only doing this in 368, this is going to continue to build into 379. And there's a couple chapters where this is extended. We keep going in this direction, and so you'll continue to see this concept. So it's fundamental. It's very, very important. Sampling distributions are approximately normal. This is a hugely important concept. Okay, for example, the sampling distribution of St. Andrews College SAT scores. So we know, I haven't said it explicitly, but I did suggest this earlier, that the sampling distribution of the population mean is unbiased, meaning that the expected value of x bar is, in fact, the population proportion, the true population proportion. So I can draw a normal distribution because, according to the central limit theorem, sampling distributions are normally distributed. So I can draw a normal distribution, and then I can center it on my population mean because I know what that is, 1697. And I can compute my sampling distribution's standard deviation, standard error of the sampling distribution, as 87.4 divided by the square root of the sample size, square root of 30, which gives me about 16. So I have mu equals 1697 and sigma equals 15.96. I have a regular, at this point, I have a regular normal distribution, straight out of chapter 6. How we got here was a bit convoluted, but we've got a regular normal distribution. And so we can ask the same types of questions we asked in chapter 6 to address questions about the sampling averages. So like, what's the probability of a sample average being? These kinds of questions. So, for example, what is the probability that a simple random sample of 30 applicants will provide an estimate of the population mean SAT score, and that population or that sample mean will be within plus or minus 10 points, so the SAT points, out of within 10 points of the actual population mean mu. So given that the population mean is actually 1697, what is the probability that our sampling distribution's average, our x bar, will be between 1687 and 1707, right? So 1697 minus 10 and 1697 plus 10. Well, we've got a normal distribution, mean 1697, standard deviation 15.96, and we have two values of interest. So what I've told you before is that anytime you have a question like this, you should draw a picture. It will help, I promise. I've taught this class for a couple years, and when I was in grad school, I was a teaching assistant for a stats class, and I taught this class for 3 years as a TA. And students never take my word for it. They see it in the lecture, and they're like, oh, yeah, it's cool. I don't need that, though. And then it always helps people. I've been doing this for years, I promise. All right, let's start by drawing a normal distribution. It's a little tilted. That's the ground. It's not flat. I'm sorry. Now, this is our sampling distribution. So it is centered on mu. It is centered on 1697. All right. So we're interested in the interval between 1687 and 1707. So this is our first point of interest, x1. This is our second point of interest, x2. And we want to know what's going on here in the middle. All right. Now, here's the trick. Normal distribution tables, the ones that we have in the book, the ones that we've been using, only give you cumulative values from left up until the point, like this, right? So I can't actually compute this value. I can look up this value in here, right? And I can look this one up. And I can look the big one up. Yeah? I can look up the little piece, and I can look up the big piece. So what I then can do is I've got, oh no, I'm counting this piece twice. So I take the big piece and I subtract away the little piece. And that will give me the piece in the middle. Now I have, that might be a little hard to follow with my doodles, but what you'll see in a second is a broken out version of this, and that will hopefully help you understand. So step 1, calculate the bigger portion. Well, the bigger portion comes from the bigger number, so 1707 is our x value, and we plug that into our z transformation formula. X minus mu over sigma. Now, this time, we're not using the sigma of the population. We're using sigma for the sampling distribution. So this is sigma x bar. 1707 minus 1697, quantity divided by 15.96, which, of course, we already know. We artificially created the value 1707 by adding 10 to 1697. So obviously, if we subtract the 2, we'll just get 10. So this is 10 over 15.96. 10. That was a weird twang I had in my voice. Oh, my enunciation is so poor. 10 minus 15.96, which is, about 0.63. And then we're going to look up 0.63 on the standard normal table, on the Z table, and that will give us a probability of 0.7357. A cumulative probability. Now, if you don't remember how the table works, it looks like this. 0.63 was the number we're looking for, so if we find it right here, 0.7357. Okay, so we're running out of time. I need to go through this. So, part 1, the big piece, as I'm calling it. The big piece here, the big thing that I filled in, that is 0.7357. But we need to subtract away the part that is less than 1687. So step 1, part 1 is complete. Now step 3, step 4, calculating the Z value at the lower endpoint, which is going to be 1687 minus 1697, which is of course negative 10. Same thing. This is minus 10 from the mean. So minus 10 divided by 15.96. Same thing as positive 10 divided by 15.96, except it's negative. So same number. And again, you don't have to do it in your head. Plug it in the calculator. Negative 0.63. There it is. And then we look up negative 0.63 on the Z table, and we'll find a probability of 0.2643. For time, I'm going quickly. Of course, you can feel free. I'll upload this after class. Feel free to watch it. So what we just looked up was this value right here, this little guy on the end. So we looked up the big piece. We've looked up the small piece, and now we need to subtract the small piece from the big piece. So we're going to subtract the probability of Z being less than 0.68 minus the probability of Z being less than negative 0.68, which is 0.7357 minus 0.2643 equals 0.4714. So calculate this number, plug them in, and subtract them. So, in summary, we can say the probability that the sample mean SAT score will be between 1687 and 1707 is 47.14%. About 50%, a little bit below that. So pretty close. And this is what it looks like graphically. So this is what I was trying to illustrate to you with my little confusing mark. It would be better with an eraser where you can, kind of erase the part that you're not using. What I would actually do in practice is I would just draw this. And I would understand that I needed to compute this and then subtract a little piece off. That's what I want you to get to. But my illustration might have made some sense. And hopefully adding this in with the more professional document, more professional images will help. Okay, so you can read this if you want. I'm not super worried about it. It's not that big of a deal. And this takes us into the proportion. So we're going to skip past all this. Skip. All the proportion stuff, skipping all the proportion stuff, Yeah, and then slide 54. So this is where we're going to pick up on Wednesday. Don't forget about your vocab quiz. I'm going to get those words selected for you, and I'll have those uploaded in just a few minutes. That is it for lecture today. We're done right on time, 8:19 Central. Easy. You right, Ben. It's just chapter 6 all over again. No, you don't have to re-register. You should be able to just see it, which in fact doesn't it show up for you in your D2L list? You should be able to see your shells. Let me show you what I'm talking about. You should be able to click on your list of shells and see what's coming. So, like here's my summer class, 377 section 2, 377 section 3. These are in the summer. And then I've got analytics 1, analytics 2, or I guess it's 5, and applied business research in the fall. So you should be able to see what's coming up. We only use one table. Good question. So the table, depending on where you find it, will be the one that I've put on D2L, which you're, of course, encouraged to use. Let me show you my little table that I have here. I'll need to zoom in to make this easier to read. Can I do that? I can't do that, can I? That's awkward. Okay, what if I change the view to large icons? Is that any better? It doesn't. Ooh, there it goes. The pictures are just getting bigger. Okay, well, what matters is there is a positive, there is a negative side, and then I use the PDF combiner to put them together. So then it looks like this. So you see on page 1 are all the negative z's. It starts out with very, very small numbers, close to 0, negative 3.4, and then as z gets bigger, the probability climbs until you have around 3.4, 3.49. It's quite close to 1. So it depends on how you look at it. It should, in the book, be considered one table, but it may be 2 pages. Yeah, I did. It's on D2L. Content, and then you go to exam prep materials, exam 2, normal table combined. So any like formula sheets or things like that are under exam prep materials. Everything's here, including exam 2 Jeopardy. Okay. Can I be aware for vocab quiz? Is it before class Wednesday or after class? Neither of those are what we did last time. It's during class. During class. We'll do it right at the beginning of class. It's not too late to register for summer courses. No, I do not believe it is. My understanding is that you can still register. I got an email from the provost last week trying to encourage people. However, they're starting to cut down courses. Apparently, summer registration is awful. It's some of the worst it's ever been for obvious reasons. But nonetheless, people aren't signing up for summer classes, and so they're starting to shut down sections that don't have enough students. So you need to go ahead and get registered if you're going to register, so that if there's maybe your section will get closed if you don't register in time. So yeah, so make sure you get registered soon. And it's probably actually too late. Maybe not. But I got a call from the department chair a couple days ago. No, if you signed up for classes, so first of all, if you're signed up for summer 3, which is it's the second half, it's not online. If you are in a full summer, which is summer 2, or the first half of summer 1, and those classes are just converted to online by default. You don't have to re-register for anything. I don't think I've been told that I may be getting a section for spring term or summer 1. I don't think I've been given it yet. Let me see. Should be, yeah, I don't think so. If you get a negative number, look it up on the negative table. Don't overthink it. Just look up the number you have. All right? So like if you get negative 2.6, look up negative 2.6. Negative 2.6. Negative 2.6 is really negative 2.60. So negative 2.60, that's this one right here. If you get negative 1.75, then you look for negative 1.7. You go negative 1.70, 1.71, 2, 3, 4. Negative 1.75 is this one right here. So don't overthink it. Just look for the number. If you subtract from 1, you don't subtract the z value. You subtract the probability from 1. That's a very important distinction. If you have to subtract the probabilities because you want to look the other direction, right? This table goes from wherever you draw the line, it goes to the left. This is my left. I'm not sure how it looks for you. From here to the left. Go ahead and tell me in the chat, by the way. Is this your right? Is that way right? Is that right? That's right. Okay. That's what I thought. It is flipped. Okay. So that means this is the left. The table starts here, and it's cumulative everywhere from negative infinity all the way up until this point. If you want this point and more, then you look up the value on the table. Let's say it's negative 2, for example. Exactly negative 2. Then you go negative 2.00. That's 0.0228. And then you would say, I want 0.0228, but I want it to the right. So that's 1 minus 0.0228, which is 0.9772. Does that make sense? Yes, Dorothy, you will see me in person. Fingers crossed. They haven't made any officially. It's summer 3. If you're taking, for example, if you're taking my analytics class, my production operations management class in summer 3, that is currently still scheduled for face-to-face. Who knows? If the curve isn't flattened like we think it's going to be and the virus is still really bad, we may still be in quarantine. There's no way to know for sure. I hope not. What I tell myself and I tell other people is if you want the quarantine to be over soon, then do the quarantine. Don't cheat it. Don't go over to your friend's house. Don't invite people over for family dinners, which I've given my mom a lot of crap. My aunt is a nurse. She works in a hospital where they treat the coronavirus. And my mom's like, well, it's Easter. We have to have everybody over. I said, no, you really don't. There's a virus, and it's killing people. And if we don't control it, it will go crazy. But here, there are very, very few cases. There are only a couple hundred cases, like in the whole part of the state. Nashville has a ton of cases, but Knoxville, which is 3 hours away, has almost none. We have very, very few. So anyway, point is, if you want the virus to go away, then be the kind of person you want to see in the world. Embrace the quarantine, even though it's awful. It's the only thing we can do right now. Where's your ball? The cat realized that there are ping pong balls on the ping pong table, and he has a blast. You could say he has a ball, but you probably wouldn't. Okay, did I miss anybody else's question? I think that's everybody. Okay, well, I'm going to cut the video here. I'll be hanging out in the chat for a little bit if you want to talk to me. Cutting the video here. I'm going to work on those vocab words, get those uploaded. So, for all you video folks, see ya.